Greetings, mass spectronauts. In this video, I will be giving a brief introduction to Discharger. Discharger is a new tool that we're currently developing and which will soon be part of the AutoVector suite. It provides a charge state deconvolution capability, aimed initially at antibody analysis, but which will work for general intact mass protein spectra. The AutoVector suite is a collection of mass spectrometry data processing modules that can be configured into a wide variety of data processing workflows. The first tool was AutoPhaser. It automated the phase correction of FTMS data to allow it to be presented in the absorption mode. Having developed an absorption mode capability, we then began to develop tools to help process these files efficiently. AutoPeaker is AutoVector's robust peak picking tool. Autologous provides automated assignment of complex organic matter spectra. AutoFragger and AutoSeeker provide the top-down protein assignment capability. AutoQuis is a new tool we developed to help users import MZML and other mass spectrometry interchange format data into AutoVectors, so it's no longer limited to FTMS data processing. Discharger is our new tool, still in the beta stage, that can be used to deconvolve intact mass protein spectra, such as for intact monoclonal antibody analysis. So if you're an existing AutoVectors user and you'd like to try out the new Discharger capability, please get in touch and we can supply you with an upgrade that includes it and that will continue to work with your current license. We'd really like to get your feedback so we can develop the tool to best meet your requirements. In this quick demonstration, we will deconvolve an intact mass dataset for the NIST antibody. In this example workflow, the data file is a Bruker ICR file, so we'll start by phase correcting the spectrum into absorption mode. We've looked at what AutoPhaser does in other videos, but if you would like to know more detail about what AutoVectors is doing during phasing, then please get in touch. But now the phasing process is complete, and we can see the mass spectrum in both magnitude and absorption modes. As is normal with intact mass antibody spectra, we can see a number of different proteoforms in different charge states. In order to be able to assign the proteoforms, it can be useful to deconvolve the charge states, and this is what we'll use Discharger for. To access Discharger, go to the Spectral Info tab. You can find links to other tools in the AutoVector suite on this tab. If you want to get trained on any of these, then we can easily arrange a WebEx. But for just now, here's the link to Discharger. Here's the Discharger interface. Over here is the process spectrum file that AutoVectors automatically save to import the data into Discharger. Here is where you can load up a FASTA format file to define the expected protein sequence. This doesn't have to be 100% accurate at this stage. In fact, you don't even have to include all or even any modifications. However, if you want to add specific modifications, here is where they can be entered. On this side of the screen, you can see the mass spectrum before deconvolution. To start the deconvolution process, click here. This display shows Discharger testing different charge state probabilities. Once the deconvolution process is complete, Discharger uses AutoPeaker to peak pick the deconvolved spectrum. Now the spectrum has been deconvolved and the peaks have been detected, Discharger now jumps to the Deconvolved Spectrum tab. The deconvolved spectrum is shown in green here, and the peak list is shown here. This is a CSV format peak table that can be simply copied and pasted into Excel. If we go back to the deconvolved spectrum, this white peak corresponds to the unmodified protein, because we didn't add any modifications into the control. However, you can see that the deconvolution worked even without this. But for the purposes of this demonstration, let's add a glycosylation modification and rerun the deconvolution with that in place. Now, the model distribution aligns with one of the proteoform peaks in the deconvolved spectrum, so let's zoom in to look at the detail. You can see how well the peak shape in the deconvolved spectrum in green matches that of the modelled isotopic distribution for this proteoform in white. The other peaks that can be seen correspond to the contributions made to the deconvolved spectrum from the various charge states that were combined to produce it. I hope you've enjoyed seeing this demonstration of the new Discharger tool for AutoVectis. Remember, if you're an existing AutoVectis user and you want to try it out, I can send you an updated installation file with Discharger included. Your existing license will continue to work with this. If you're new to AutoVectis and you want to try Discharger out, then just contact me through the kilgaralab.com website and we'll see how we can help you. Thanks for watching and happy mass speccing.